Hey, Adam.
Hey, Brandon.
Can you help me with this problem real quick, bro?
Is it the homework that Mr. Friend gave us?
Yeah, man, I don't get it at all.
I'm stuck on it also.
Something about like integration or
derivatives or something.
I don't know what it is.
Hey guys,
Hey, what's up,
Hey
man?
guys, hey,
How you doing?
How you guys doing?
Do you guys know how to do this? We're really stuck.
dude, I wish.
Yeah, it doesn't make any sense.
No, this is just power rule. You just got this. Come on.
But man, if there was only an easier way to do this.
There is.
Hey.
So this is the chain rule. This one's also really simple to do, exactly like the power rule. So what you would do is write y prime, and then you would multiply the constant and the exponent together to 28, and you write the regular whatever in the function. And then you would, don't forget the -1 up here. So that would be 6, and then you multiply by whatever the derivative of the inside of the function is. So for this one, it would be minus sine x. And for this one, you would do the same thing. Y prime equals, and then constant, so 5, and then derivative, the same inside, 2x to the 4th plus 6x, and then -1, so 4, then times the derivative of what is inside. So that would be 8x to the 3rd plus 6. And those are your answers.
Alright, this is the power rule, and then this is real simple. Basically, you use the exponent, multiply by the number in front, so you get 12, and then subtract this one by 1. So you get x to the power of 3.
Okay, this is a little different one. It's much more complicated. Not really. But you just multiply that, and there's a 1 right here, so it's going to be 8x to the 7th because you subtract this by 1. So then it would be 60 right here, 4 right here because you subtract it by 1. It's going to be minus 16x to the 3rd, minus it by 1, multiply it by 4. Then this is going to be 30 to the 2nd because that, like that.
Alright, so here we have the product rule. This is the formula. So basically it's the derivative of the first term times the second term plus the first term times the derivative of the second term. Now here we have the two terms which are f of x and g of x. So we simply just plug them into the formula right here and simplify and add these two together, and our final answer winds up being 30x to the 4th plus 54x to the 5th.
So here we are doing the quotient rule, and this is the formula you use. And this is the problem we are doing. This is number 1. So on number 1, you would take f of x and g of x and plug it into the formula accordingly. And every time there's a prime, you take the derivative of it. So as you can see, I plugged in the f of x into here and the g of x into here, and then you add like terms.
Now we're going to do the quotient rule, and the quotient rule is basically when you multiply the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. An easy way to remember this is with low d high minus high d low all over low squared.
Alright, when we begin here, what we're doing is we're taking the derivative of the top, multiplying it by the denominator, subtracting it by the derivative of the denominator, multiplied by the numerator, all over the denominator squared. And then what we're doing here is distributing each of these two separately and subtracting them in parentheses. And the denominator stays the same because you don't have to multiply it out. And in the end, we get y prime equals negative x to the power of 4 minus 2x cubed plus 6x squared plus 12x plus 6 all over x to the power of 6 plus 36.
But Professor Mo, when do you use the quotient rule?
You use the quotient rule when you're when two functions are in a fraction.
Yay!
More time.
This is it.
This is it, guys.
Do you remember all of the rules from September? Functions changing the mind of students while deriving example A. Our minds are raking about the idea of taking one number from the power and descending it to the constant.
the chain rules with you. It is pretty easy to do, but just need to multiply. Remember to subtract by 1.
Now the quotient helps you out when you have one fraction. Having two functions is one fraction. Using the LDI method. Something you remember, deriving in September, deriving is a piece of cake.